Okay, Assalamu alaikum. Am I audible?
Yes.
Okay. So we shall start the session now.
Sorry?
Yeah, am I audible?
Yes.
Okay. Fine. So let me first share the screen. Let me open the module first. Okay, now I have shared the screen now. Can you be able to see the screen?
Yes.
Okay. Can you just remind me where we stopped in the last class?
I think it was after balancing some equations.
Yeah. I remember I taught the synthesis
Yeah.
and decomposition, and did we study this combustion part also?
Yeah. I think so.
As far as I remember, I don't think so. Yeah, I think I stopped at this synthesis part. I didn't start this decomposition, I think. Am I right? Because
I think you
I don't
just
remember
quickly
this
went over
H2O2
decomposition.
gas. Yeah, I'm sorry.
I think you quickly went over decomposition, but didn't go like in depth.
Okay, then fine. So we will start from this decomposition. Are you okay with that?
Yeah.
Okay. So synthesis mean like collecting together. Decomposition means simply we can say splitting, right? So the opposite
Yeah.
of synthesis. Now the general form of this synthesis reaction is given here. AB gives A plus B, but the opposite of the same reaction will be synthesis reaction. Okay, so you just see this example. For example, the electrolysis of water. So electrolysis, have you studied about this term electrolysis earlier?
Yeah.
Okay, can you?
You.
Yeah, electrolysis mean we are going to split compounds into its smaller components using electricity, right? So that is the basic idea behind this electrolysis. Okay, so the methodology that we use to split water into its simplest molecules. So now if you look at this H2O, H2 and O2 are the simple components of H2O, right? So using electrolysis, by applying electricity, we can split H2O into H2 and O2. Okay, so you see now AB, if you consider this H2O as AB, now we are just splitting, right? So A plus B, H2 plus O2. Then you just see this is right. Now the method that we use for this reaction is electrolysis, right? So this is heating reaction, right? So by heating copper carbonate, we can split copper carbonate to copper oxide and CO2 gas, right? So this is the methodology that we use here is heating, right? So the color of copper carbonate is green, right? So initially it's in green color, so you should remember the colors of some particular compounds, right? So this is green, and copper oxide is just black color powder, right? So this is black color powder, and CO2 is a gas. Now in the test tube you take some amount of copper carbonate, which is green color. Now using a Bunsen burner, if you burn it, ultimately you will end up with some black color powder, and some gases also will evolve. Okay, right. Then H2O2, right? So H2O2 is a disinfectant, right? So you don't study biology, right? So if you have any infections for some infections, you might use H2O2, right? So if you have H2O2, we call the name of H2O2 is hydrogen peroxide. peroxide. Now if you expose hydrogen peroxide to atmosphere, it will decompose as H2O and O2 gas, right? But the problem is we cannot clearly see the decomposition, because you see here we can see the color change, because earlier it was in green color, but now it has become what, black color. But here H2O2 is also colorless. Ultimately, after the reaction has happened, the product also will be in colorless, so you cannot identify that the reaction has occurred, right? But this is a relatively slow reaction, but you can increase this by adding catalyst, right? For example, sodium and all, right? So sometimes you might have seen some videos, right? So if you just take some H2O2, right? So you just put some H2O2, after that you put H2SO4, and if you put sodium, and with soap, if you use soap bubbles, then you can observe some foams, right? Foams in the sense, you know, bubbles, right? So this is called elephant toothpaste, right? So if you just click on this green color text, it will direct you to a video, so you can just see that, right? So how the reaction is used to make some colored foams, right? So the basic idea is oxygen. Now in order to make the reaction happen fast, we will add some catalyst, but the thing is, now you see oxygen, right? Oxygen is evolved. Now if you use bubble, the bubbles will mix with oxygen, and they will be pushed outside, right? So you can see some foams will be formed, right? Foams will be formed. Then combustion. Okay, so combustion, as I already told you, it's just burning, right? So if you want to burn, oxygen is used as oxidant, right? So you see now combustion is the reaction between substance and oxidant. So oxidant, here we usually use oxygen, right? Releasing exothermic and producing. Okay, now if you just look at this chemical reaction, now the substance that we are going to burn is sulfur, right? So that is in solid state. Now the oxidant we normally use in the atmosphere, according to proportion, we have nitrogen in large quantity. What is the percentage? What is the percentage of nitrogen in the atmosphere?
Sure.
I'm sorry?
I'm not sure.
Okay, so in the atmosphere, if you draw a pie chart, okay, now it's not okay, right, now 78% we have nitrogen, okay, 78% we have nitrogen gas in the atmosphere approximately, and oxygen gas we have 21%, right? But oxygen will involve in the combustion reaction, okay, right? Now if you burn something, oxygen will come to play, right? Oxygen will play the role of burning that substance. Now what will happen is, after the combustion reaction has finished, we will end up with sulfur oxide, oxide of some substances, any substance. We can burn any substance, but we will end up with oxide, right? Oxide of that particular substance, right? Here sulfur is burnt, so we get sulfur oxide, right? So you just see this, read this one. Balancing oxygen using fractional coefficient is commonly used in combustion reaction to standardize equation undergoing complete combustion. So okay, now here they have mentioned complete combustion. So we have two types of combustions. One is complete combustion and the other one is incomplete combustion. Have you studied about these classifications earlier?
No.
Okay, sorry?
No.
Okay, so we have complete combustion and incomplete combustion. So complete combustion in the sense, if we supply oxidant in sufficient amount, we call it as complete combustion. When the oxidant is insufficient, we say that is incomplete combustion. So can you understand the differences between the complete and incomplete combustions.
Yeah.
If the oxidant here, what is the oxidant here? Oxygen. If we supply excess amount of oxygen, we call it as complete combustion. So it will result oxide. It will result oxide. For example, if I take a simple example, you just take carbon and you just burn it. So when I say the word burn, you will make the substance react with oxygen, right? So what will it result? What will it result? Carbon dioxide, right? Okay. Now now can you check if the reaction is balanced here?
Yeah.
Yeah. So you see 1 mole. So what does it mean? 1 mole of carbon is reacted with 1 mole of oxygen to produce 1 mole of carbon dioxide. This is the meaning of the coefficients, right? So we normally tell stoichiometric coefficients. You know stoichiometric coefficients, right? So a chemical reaction will occur based on the stoichiometric ratio, right? So if I want to burn 1 mole of carbon, I will require 1 mole of oxygen. Then only I can produce 1 mole of carbon dioxide. Now let's say we have 1 mole of carbon, okay? So we have 1 mole of carbon, but we have only a half mole of oxygen, right? So we say 0.5 oxygen. So will this reaction happen? Will this reaction happen? Can I produce carbon dioxide?
Yeah.
Okay. Now let's assume during this reaction carbon dioxide is produced. Now can you check if the reaction is balanced?
No.
No. So can you try to balance it?
That's a 5. I don't think you can, right?
Yeah. Here we cannot balance this reaction because we have 1 mole of carbon, right? So here we have only how many oxygen molecules we have?
You have 10.
10. How?
5
How?
and 2.
Okay. How many? Okay. How many oxygen atoms do we have in this reaction?
That's a. Oh, is that 0.5 or just 5?
Yeah, this is 0.5, 0.5. So
okay,
0.5 mole of oxygen. So we have only one
thought it was
oxygen,
just 5,
right?
yeah.
One oxygen. But in the product side, we have 2 oxygen, right? So even, okay, now let's say if we put half again, then I have to alter this carbon again. That is not possible. We will struggle here, right? So what does it mean is this reaction is not practically possible. It will not happen. So if we, for 1 mole of, let me use a different color. For 1 mole of carbon, if you supply half mole of oxygen, only CO, carbon monoxide will be produced, right? So carbon monoxide will be produced. But in a combustion reaction, we should result the oxide of something, right? Oxide of something.
Yeah.
So this is carbon dioxide, this is carbon monoxide. So this is called complete combustion. How do we call it? Complete combustion. Complete. And this is called incomplete combustion. This is called incomplete combustion. Okay, incomplete. So in incomplete combustion, we will use half ratio of oxidants, right? Do you understand? In incomplete combustion, we will use half ratio of oxidant, right? So here the oxidant is oxygen. Now you just see this example, right? You just see this example. Now here, right, now you see here we use half ratio of oxidant, but we produce carbon dioxide. Is it a complete combustion or an incomplete combustion? Incomplete. Why do you say so?
Because you have.
Because we use 12.5, right? But I already told you, in a combustion reaction, carbon dioxide will be produced. If we result oxide, then it will be called complete combustion, right? Complete combustion. But okay, now can you just, okay, now I will just erase. Okay, now you don't consider these coefficients of the molecules. can you try to okay, now if I give you only the reaction, okay, so this is a organic molecule, this is an organic molecule, right? C8H18 is an organic molecule. What is organic molecule?
Not sure.
Okay, now if we have direct bond between carbon and hydrogen, we call them as organic compounds. For example, CH4, right? Methane. You know CH4 methane?
Yeah.
Okay. So can you try to sketch the diagram of CH4?
Like that, right?
Right, okay. Now here between carbon and hydrogen we have a direct bond, right? So such
Yeah.
molecules are called organic compounds, right? So we will study about organic chemistry is a vast area. Right. Now you just see this example. Now this is an organic molecule. Now we make this organic molecule react with oxygen, right? So what will it produce? It will produce carbon dioxide and H2O, right? So you just in a combustion reaction we will end up with carbon dioxide and water, right? So how you can assume this is, now in organic molecules we have carbon and hydrogen. What is the oxide of carbon?
Carbon dioxide.
Carbon dioxide. What is the oxide of H? Hydrogen?
Hydroxide.
Water. Now okay, now you just bear this point in mind. In combustion reaction, oxide of the atoms will be formed, right? Oxides of the atoms will be formed. Now you see we have only one individual or solo atom here, so it will produce its oxide. What is the oxide of sulfur?
Sulfur dioxide.
Sulfur dioxide, right? Here you see carbon hydroxide. Here we have two atoms. What are the two atoms here we have? Carbon and hydrogen. Now we will just assume the separate atoms are reacted with oxygen. So if I react carbon with oxygen, it will produce carbon dioxide. Now let's say we have H2, right? H2, right? Hydrogen also we have. Then we make this H2 react with oxygen. What will it produce?
Hydrogen, like just water, so H2O.
H2O, right? So you just assume carbon. Okay, now here we have carbon. You just split through this. So carbon is reacted with oxygen to produce carbon dioxide, and hydrogen is reacted with oxygen to produce H2O. Now can you try to balance this chemical reaction? Okay, now let's say we have been given an unbalanced chemical reaction of the combustion of this organic molecule. Can you try to balance it? I will just okay. So the chemical equations that we have been given is C8H18 plus O2 gives you CO2 and H2O, right? So in an examination we will be given this equation and be asked to balance it, right? So without seeing the balanced chemical equation, can you just try to balance it by yourself?
We've got 18 hydrogen, that's I need a 9 here for 18 hydrogen, and then we have 8, so that would be a little bit full. The water is 8. Then like this. We've got 25, got that 2, yeah.
Yes, very good. So you started with balancing hydrogen, but how you have to do this question is you should start with this carbon. Okay, you should start with this carbon, right? So since we have 8 carbons here, first you should put 8 carbons here, right? After that only you have to count the hydrogens, right? So here, how many hydrogens do we have? 18, right? So we will have 9 here. After that you will count the oxygen and balance the oxygen. Here you see, normally we don't like to have decimal numbers in front of molecules, right? But why they have given this is we might study about enthalpy of combustion, right? So when we define the term enthalpy of combustion, so enthalpy of combustion means how much of energy is required to make this reaction happen, right? So that is the definition. So when we study energetics, hopefully energetics, we will study about different enthalpies. So one of them is enthalpy of combustion. So if we want to make this reaction happen, now here we don't require energy. Energy will be produced. Why? Because this is an exothermic reaction, right? So when we burn, you will feel heat. So energy will be released to the system. So it's an exothermic reaction. So it will be negative. So delta H. Have you studied about delta H and delta S, so those things?
I've studied delta H, not delta S.
Okay, right. So here you see, wait. Okay, now here we have 12.5, right? So normally we don't like to have fractions as a coefficient. So what we'll do is we have to get rid of this fraction. So for that, what can we do?
Double everything, right?
Yes, what can we do for that? To get rid of this?
22, and then 25, and then 16, and then 18.
Very good, very good. You just multiply the entire reaction by 2, right? Okay, but that is how it should be written. But for mentioning the enthalpy of combustion, we have to have the substance which is burnt as one mole. That's why they have given in this format, right? So but typically how we have to write this as 2 and here 12, then here 18, 16 and 18. So normally we should write in this way. But when we define the term enthalpy of combustion, the substance that we burn should be one molecule, one mole. For that we have to divide this by 2, and for that we cannot do anything. Here we should have fraction. Okay. Right. Now another example is also given here. We will just quickly. Right. So this is also an organic compound, right? So here okay, now we will just split this, right? C, H and O. So C will react with oxygen and produce CO2, and H will react with oxygen and produce H2O. Will oxygen will, okay, now we don't consider, right? So will oxygen react with oxygen again? No, so we don't need to consider about that. We have to consider the distinct atoms only, right? Different atoms.
Yeah.
Okay. So the products of this reaction is also CO2 and H2O. Now can you try to, okay, now we will just see this example. Okay, they are same. Yes, right. There is a comparison between complete combustion and incomplete combustion. Okay, so we will just see that. Right. Now you see, here we use 1 mole of this organic substance, and here also we use 1 mole of organic substance, right? Okay. Now, okay, in order to produce carbon dioxide through this combustion reaction, we will need 3 mole of oxygen. But if we have less amount of oxygen, let's say we have only 1 mole of oxygen, right? So in that case we will not get carbon dioxide, we will get only a black color powder, which is carbon carbon, which is pure carbon, right? Okay. Now if it undergoes, now the name of this organic substance is ethanol, right? So if you try to sketch the diagram of this C2H6O, it will be like this: CH3 CH2OH. Okay, now that is not required here, but when we study organic chemistry we will study about that later.
Okay.
Right? Okay, now when ethanol undergoes combustion with oxygen, it will produce carbon dioxide and water. When it undergoes combustion means when we generally tell combustion, it refers to complete combustion. But if it is incomplete combustion, we should specify that. Okay, so when ethanol undergoes incomplete combustion, it will produce carbon, soot and water. Carbon, soot means, what is soot? What is?
Is that the solid?
Yeah, soot means it's a black color powder, right? So if wood is burned, then the final product is soot, right? And so you see now ethanol is burned with less amount of oxygen, so it will undergo incomplete combustion, so it will produce carbon, soot and H2O gas. So ultimately what you can observe is, after this reaction has happened, you will not have anything in the system, because everything has been evaporated as gases. But here what will happen? So okay, now let's say you take some ethanol is liquid, right? So ethanol, and you burn it, right? So using a Bunsen burner, you burn it. So you just burn them. So if you use sufficient amount of oxygen, right? So if you use sufficient amount of oxygen, ultimately you will end up with an empty boiling tube, right? Because where are the products? Because all are in gaseous state, all will go outside, all will go evaporated, right? But here if you use less amount of oxygen, ultimately we will have black color powder. So in that case it indicates it has undergone incomplete combustion. Okay, right? So these are the differences. And now can you just read this? By providing opportunities, okay, that is not required, right? Precipitation. So precipitation, what do you understand by the term precipitation?
It's the formation of a solid substance.
It's the formation of solid substance. You just see this general equation: AB aqueous, right? CD aqueous,
Yeah.
AD aqueous and CB solid. Now a solid substance is formed, right? So this is called precipitation. So initially, let's say we pour AB and CD as liquid state into this boiling tube. Ultimately what will we have? We will have a precipitate. We will have a precipitate like this and an aqueous solution. So this is called precipitate. This is precipitate and this is solution. Okay, this is solution. Now if you take some example, sodium chloride AgNO3. So you don't need to remember this, by heart this chemical equation. You just see how they dissociate, right? So Na plus NCl minus, Na plus NCl minus, and here Ag plus NO3 minus. So here Na is reacted, or Na has bonded with chlorine, but when this reaction happens, this Na will make a new bond with NO3 minus. So it will produce NaNO3, and this Ag and Cl will make a new bond among themselves. So AgCl. So you should know the physical states of these individual compound. So NaCl is aqueous, right? So aqueous mean a solute is dissolved in a solution, right? So in a solution we have solvent and solute, right? So solution, right? So solute is NaCl. Normally NaCl exists as solid, right? For example, salt, right?
Yeah.
Salt, domestic salt. So if you dissolve salt into water, you will have NaCl aqueous, and AgNO3 is also a chemical solution. So ultimately you will have a precipitate. So initially you didn't have any solid substance, but after this reaction has finished, we will have a solid substance. Okay, so this is the formation of precipitate. So what is the color of this AgCl? Okay, AgCl is white color precipitate, right? So this is a white color precipitate. Now when we study inorganic chemistry, we will focus on the colors of some popular organic species. Okay. Right. So precipitation reaction can also produce two insoluble products, for example magnesium hydroxide. Now here we have two kinds of products. One is solution, the other one is solid, but both might be solid, right? So here you see barium hydroxide, magnesium hydroxide. Now whether a substance will be solid or a liquid will be determined by the KSP value. You didn't have studied about the KSP values and other stuff, right? KSP, physical chemistry. Okay, doesn't matter. Okay, so here you see barium sulfate and magnesium hydroxide. Now you see, you might think how we say NaNO3 is aqueous and barium sulfate is solid, right? So this is determined whether based on the value of KSP, right? So for each and every chemical species we have KSP. Based on that we will tell whether it will be solid or liquid. Okay, so that is a different chapter. Now you just frequently see the physical states of each chemical species and remember in which condition they exist. Okay, right. Now barium hydroxide. So can you just tell me how this barium hydroxide will dissociate?
Into barium and hydroxide.
Barium 2 plus and OH minus. Barium 2 plus and OH minus. Here Mg2 plus and SO4 2 minus. So here the cation barium 2 plus will react with SO4 2 minus. So it will result barium sulfate. So it's an insoluble product. It's an insoluble product means it doesn't react with water. It doesn't react with water. Now you see in the system we will have water. If it exists as solid means it doesn't dissolve in water, right? It doesn't dissolve in water. So that's why we say insoluble product. In the system definitely we will have water. Why? Because in the reactant we have water. After the product has been formed, now it still exists as solid means this species cannot dissolve in water. Not all the substances will dissolve in water, right? For example, glucose will dissolve in water, but if you put a brick in the water, will it dissolve?
Sorry?
If you put if you put a stone, right? If you put a stone into water, will it dissolve? No, right? So not all the substance will dissolve in water. So barium sulfate is insoluble product. It is not soluble in water. Okay? Right. Students can practically explore. Right. Now acid base reaction. So can you just try to define the term acid and bases?
An acid is a
Can you just tell me some examples for acid?
hydroxide.
I'm sorry?
Hydroxide.
Hydroxide.
Wait, no. Not hydroxide. SO4 2 minus.
SO4 2 minus. SO4 2 minus.
Yeah.
Okay. Right. So SO4 2 minus is not an acid. So okay. Now generally HCl, hydrochloric acid, right? HCl,
Yeah.
H2SO4, sulfuric acid, H2SO4, sulfuric acid, and HNO3, right? So these are famous acids that we use in the chemistry laboratory. I'm sorry, HNO3, nitric acid. Okay, right. Now, okay, NaOH, sodium hydroxide, is a popular base that we use in laboratory, right? Okay, now just tell me how this HCl dissociates. H plus and
Hydrogen.
H plus and Cl minus, right?
Yeah.
H plus and Cl minus. Now we are only interested in the H plus, right? Now if something dissociates H plus into aqueous solution, it is called acid, right? Now again H2SO4, how will it dissociate?
H plus.
H plus and SO4 2 minus, H plus
Yeah.
and SO4 2 minus, right? So if it releases H plus ions, then it will be called acid, right? And here also we will have H plus and NO3 minus, H plus and NO3 minus, H plus plus NO3 minus. Okay, so what we are interested in acid is H plus. Okay, now here NaOH, we have NaOH. How will it dissociate?
Into sodium and then hydroxide minus.
Na plus and OH minus, Na plus and OH minus. So here we are interested in OH minus, right? If the meeting ends, you can use the same link to join. Okay, I think within 1 minute if it ends. Okay, so Na plus and OH minus. Here we are interested in OH minus, not in this cation. Okay, right. So now the basic formula or the general formula of acid is HA, right? HA. Here you see BOH, right? So this A can be anything. It can be Cl minus, it can be HSO4 2 minus or NO3 minus. That's why they have given a general letter A, right, to indicate the anion in the acid, right? In BOH, this B belongs to this Na plus, the cation after dissociation, right? So it can be anything. If we have a okay, right? Okay, so here okay, so here this HA will dissociate as H plus and AH minus. Okay, here it will dissociate as H plus and AH minus, H plus and A minus, right? Because I wrote like this, HCl, H plus and Cl minus, right? So here A minus, okay, A minus, and here this will dissociate as B plus and OH minus, B plus and OH minus. So here double displacement here double displacement reaction will happen. So this H plus will react with this OH minus, so it will produce H2O, right? So it will produce H2O, and this B plus and A minus will react together to form Ba aqueous. Okay, so this is the general thing, right? When acid and base react together, it will form a salt and water. So here Ba is a salt, right? Now we are going to take examples for acid as HCl and a base NaOH, right? So here H plus and Cl minus, Na plus and OH minus. So definitely during an acid base reaction water will be formed, right? So H2O, and it will exist as liquid form, right? So earlier we discussed H2O gas, but since the temperature is high there, it exists as gas, but here it will exist as liquid, right? H2O liquid, H2O liquid, right? Water will be formed because this reaction happens at room temperature itself. That's why it exists as liquid. Okay,
Okay.
right. Now again Na plus and Cl minus will form NaCl aqueous. NaCl aqueous. Why aqueous? NaCl is solid, but since we have water in the system, it will dissolve. But if we form barium sulfate, then it will not be in aqueous form because it is insoluble in water. Barium SO4, BaSO4, barium sulfate is insoluble, right? So you should know these some points, right? So earlier also we discussed, right? Where here we discussed, right? Barium sulfate is insoluble in water, so it will exist as solid. But here NaCl will be in aqueous form. Okay, right. Now okay, now we use pH indicators for determining whether a substance is acid or base, right? So we have some indicators, right? Normally we use pH paper, right? We have different colors, and by comparing the colors we can tell the pH value. We have pH value till 14, right? So if it is 7, we say it's neutral. You know these things?
Yeah.
Okay, right. Now pH indicators, pH probes. pH probes mean in the modern technology we have pH probes, right? So normally if we use pH indicator, we have to compare the color and determine the pH value. But pH probes, if you use pH probes, now this is technologically advanced indicators, it will directly display the pH value in the digital system. That is the difference.
Okay.
Now acid carbonate reaction. Okay, right. Now now this is what you have to bear in mind. When carbonate reacts with acid, what is the symbol of carbonate? CO3
CO3.
2 minus, right? CO3 2 minus. When carbonate is administered with acidic medium, it will produce H2O gas. H plus, it will produce H2O gas. Okay. So you have to write it somewhere. I'm sorry, CO2 gas. Right? So can you just tell me again? When carbonate is administered in acidic medium, then it will produce CO2 gas. Okay, right.
Okay.
Now you see HA, we have BCO3, right? So this is the condensed form of this one. This is the condensed form of this one. Okay, right. Now you see BCO3, right? So we have H plus and A minus here. We have H plus and A minus here. H plus and A minus, right? H plus and A minus. And here we have B plus and B. Okay, now can you just write the dissociated form of this BCO3?
B and then
Yeah, B plus
B plus.
Are you sure? B2 plus, right? Because you see when you B2 plus and CO3 2 minus. Now we have carbonate in the system and we have H plus also. Due to this acidic medium, this carbonate will produce CO2 gas. This is how we have to determine the product. Okay. Then we have B2 plus and A minus. B2 plus and A minus. Okay. So it will give you BA, right? So how did this water come?
Due to the presence of hydrogen and oxygen.
Yeah, Now we have oxygen and hydrogen in the system, so we don't need to write H2O, right? So when we balance the equation, we will have to balance hydrogen and oxygen. For that we will put water, okay? But during the reaction water will be formed, but not in all kind of acid carbonate reaction water will be formed. If we have extra oxygen and extra hydrogen, they will come together to form water. Okay, do you understand?
Okay.
Right. So we will just look at this example. Okay, right. Okay, so here we have HCl and NaHCO3, sodium bicarbonate. Okay, sodium bicarbonate, or we can say sodium hydrogen carbonate also, right? So we now we have to name, right? So we will study nomenclature in organic and inorganic chemistry, where we will name each and every chemical species. So the name of this one is sodium hydrogen carbonate. Why? This is sodium, this is hydrogen, and this is CO3 carbonate, sodium hydrogen carbonate. Okay, so you see here we have H plus and Cl minus. Here we have Na plus and HCO3 2 minus, right? And HCO3 2 minus will again dissociate as H plus and CO3 2 minus, right? So this is what happens here. Na H CO3. So it will give you Na plus and HCO3 2 minus. Again I am writing over here Na plus HCO3 2 minus, HCO3 minus, okay. Then again this will dissociate as H plus N, again H plus N CO3 2 minus, H plus N CO3 2 minus. So this is just an intermediate product. What is this? Intermediate mean it is not stable. Again it will dissociate as H plus N CO3 2 minus. So we call it as intermediate product. Okay, intermediate product. Okay, that is not necessary here, right? So ultimately what we will have in the system is H plus CO3 2 minus and Na plus, right? So here we have H plus and Cl minus. From here we have Na plus and CO3 2 minus. So this CO3 2 minus, due to this acidic medium, will produce CO2. Okay, then we have Na plus and Cl minus. So they will come together and form NaCl, right? And if we are left with hydrogen and oxygen, they will produce H2O liquid, right? Now can you just check if the reaction is balanced?
Believe so.
Yeah. Now what you have to understand is not always you necessary to balance the chemical equation. By default they come balanced. Okay.
Okay.
Right. Now we will move to the next part. So do you have any questions to ask before moving to the next part?
Not right now.
Okay. So do you want to mark anything?
I've been marking it as you've been saying it.
Okay. So can you just revise what we have studied so far? I will give you 2 minutes time. So here we discussed about complete and incomplete combustion. So during complete combustion, what is resulted?
Carbon dioxide.
Carbon dioxide, right? And if we supply sufficient amount of oxidant, then we will undergo complete combustion. If we have lack of oxygen, then we will have incomplete combustion.
Incomplete.
Okay.
Yeah.
Then we studied about acid and base reactions. Now can you tell me some examples for acids?
Acids are H2SO4, so sulfuric acid. HNO3, so hydrogen. What's the name for it? Hydrogen.
HNO3, nitric acid. Okay. HNO3,
Nitric acid.
nitric acid, and HCl, hydrochloric acid. And we will classify acid into different categories. We study strong acid, weak acid, and so on, right? So we will study those stuffs later. Okay. This, so detoxification of foods. So what do you understand by the term detoxification of food?
Making food so that it isn't harmful for humans.
Yeah, so we can consume it, right? So that we can consume it.
Yeah.
So D, toxic, right? So D means removing, right? So removing toxicity of food is called detoxification of food, right? So in many food we have chemical species as components, right? So if we consume excess concentration of chemical, that might be harmful, right? For human, that might be harmful. So normally when we are cooking, right? So when we are cooking, we are removing the harmness of food, right? So basically we cannot always consume the raw materials, right? So raw materials. Now you see here, we will just now this is nothing to explain regarding chemistry. This is you can understand by reading. Okay, we will just read together and understand. Okay, so this content relates to chemical process in this module to methods. They have given a description, right? Okay, now many food products consumed by humans contain chemical compounds or potentially pathogenic organisms. So what are pathogenic organisms?
Not sure.
Okay, so potentially pathogenic organism, they are referring to microorganisms. They might cause diseases to human, right? So pathogenic, what is the meaning of pathogenic?
Pathogens.
Yeah, that might cause disease in human, right? So pathogenic organisms, we have bacteria, virus, fungi, right? So and so, which can cause harm to the consumer. Processes to sterilize mean killing microorganism. You know sterilize?
Yeah.
If we are using operation tools, we will sterilize to kill bacteria and other organisms, right? Cook, bake, store food are used to reduce the instances of food poisoning that can result from the compounds or pathogens. Pathogens mean they are organisms that can cause diseases in human, right? Many examples of proper preparation foods are presented in the Safe Food Australia guide, right? So they have given some list of food that can be safely consumed by human in Australia, right? So I don't know if they will ask questions from this, right? So you can just go through these stuffs, right? Okay, now they have given some examples also. Raw chicken can contain salmonella and campylobacter, right? So these are the names of the bacteria which can cause harmness to the human, right? So they are present in the raw chicken, right? If we eat chicken without cooking, now they might cause some side effects, right? So that's why we cook and kill this salmonella and campylobacter bacteria and consume safely. Okay, right? So this pathogens can cause gastroenteritis. What is this? Okay, these are just biological terms, right? The disease names, right? So in chemistry they will not ask anything about it. But do you have any past papers?
No.
You don't take biology, right?
No.
You take physics?
Yes.
Physics, okay. So you don't need to worry about these terminologies, especially the biology terms, right? Especially the names of the diseases, right? So what you should understand is, in raw chicken we have a pathogen. Even you don't need to remember the names of this salmonella and the other pathogen,
Yeah.
but you should know these are harmful, and we might reduce this harmness by cooking, right? By cooking the chicken, we might kill, because when we increase the temperature, the bacteria cannot thrive in the high temperature, so it will automatically die and we are safe to consume it. Okay, right? So these bacteria are destroyed with proper cooking temperature, right? So if it is not completely cooked, then it is still present in the chicken, then it might cause diseases to human, right? So we have to make sure, or we have to ensure that the chicken is completely or thoroughly cooked. Then only we can enhance the safe. We can enhance the safety. Okay, right? Uncooked rhubarb contain oxalic acid and oxalate, right? So these are some instances, right? So uncooked rhubarb contains oxalic acid. Oxalic acid means C2O4 2 minus. C2O4 2 minus. Oxalic acid, H2C2O4, right? Oxalate, right? Which can cause kidney damage. So oxalate, right? So when we say there is a stone in a kidney, we say there's a layers of oxalic acid. They are layers of oxalic acid. So if a food contains oxalate, then it might deposit on the kidney surface and it might cause some stones, right? So that's why we say they might cause kidney damage, right? So basically stones are produced in kidney with oxalate deposits, right? Oxalate deposits.
Yeah.
Many types of fungi contain a wide range of poisonous compounds, right? So fungi is no, okay, now fungi. Now we can consume some type of fungi, right? For
Yeah,
example,
mushrooms.
what type of fungi can we consume? Mushrooms, right? So mushroom is a type of fungi, but not all are safe to consume, right? Some are poisonous.
Yeah.
So we have to make sure that they are safe to consume. That's in supermarkets they will be available, right? So they will conduct tests and ensure that they are safe to drink and send to the market. Okay, so we don't need to worry about that. You just read this, and I think if you click on this link you can refer more, but I don't know if they are examination oriented, but we will just study only the chemistry parts. Okay, right? Now reactions of metals, right? Now again we are coming to the reactions of metals with water, oxygen, and metals can react with acids and bases also, right? Now we will first look at how metals are reacted with water, right? Okay, now not all metals will react with metals, only the active metals, if a chemical species reacts with something, we call it as active, right? If it doesn't, it will be called passive. Okay, right? Now active metal, if it is an active metal, if it reacts with water, it will result the metal hydroxide and hydrogen gas. For example, if you take sodium and you react it with NH2O, you don't need to actually memorize this. Right? So if a chemical reaction wants to happen, electrons should participate, right? So here what will happen is this Na sodium will lose one electron and become Na plus, right? And this H2O will dissociate as H plus and OH minus, right? H plus and OH minus. H plus and OH minus. In the system, we have two cations and one anion, right?
Yeah.
Right. Now, which is more reactive, Na plus or H plus?
OH.
Okay. Now, you see, basically, metals produce cations, right? Metals produce cation. Now, we don't, it's a no, hydrogen exhibits peculiar characters. It can be either metal or non-metal. It can show both metallic and non-metallic characters, right? So here H plus has been produced, mean it is considered as a metal, right? So you might have studied reactivity series, right? Potassium,
Yeah.
sodium, calcium, reactivity series.
Yeah.
Do you know this series?
Yes.
Okay, right. So this is called reactivity series, right? So from top to bottom, the reactivity of metals decreases, right? So you just compare this hydrogen and sodium, right? So which is more reactive? Sodium. So we have two cations, right? So I told you to consider cations as boys, right? So this is a strong guy, right? So we will consider Na plus is a strong guy, and this H plus is a weak guy, right? And this is an anion, right? So let's assume this is a girl, right? So there is one girl and there are two boys, right? So who will this now let's say this is a girl, there are two boys. Whom this girl will like?
Strong.
Na plus, strong one, right? So this will make a bond with Na plus will make a bond with OH minus and form NaOH, right? And now H. Now initially OH minus was bonded with H plus, but since this saw a strong guy, then H plus, it has made a bond with that strong guy. So now the H plus is isolated. So with another isolated H plus, it will form a covalent bond, friendship, right? Friendship. Now this is like a marriage, this is like friendship, so H2 will be formed. Okay, right.
Okay.
Right. Now you see, right. Now when the reaction happens, sodium will revolve in the oxygen surface, producing a sound, right? Sound. The sound will be produced, right? And if you use potassium, right? So now if you take a potassium and put into the beaker containing water, then it will explode. So this is not nice to perform this experiment in the laboratory. Sometimes some calamities might occur, right, due to explosion, right? So we better avoid putting potassium into water, because it might result explosion. But sodium, it will be also vigorous, right? So it will produce a sound and it will produce burning also, right? So you see, ultimately you will have sodium hydroxide. So sodium hydroxide is a base, right? So it's a base. So this is a best method for producing base in the laboratory. You take sodium and react with water to produce sodium hydroxide, which is a base, and you can produce H2 gas also. Now we have to collect this H2 gas, right? So how we have to set the apparatus is, okay. So okay, now without taking a beaker, if you take a test tube, okay, right? Now you take some water and you put some put sodium solid, sodium strip, and you confine this like this, and this is a delivery tube, right? And you have to use a beehive shell, and you should have you studied the separators in your previous grades, how to collect H2 gas during this reaction?
No.
If I can wait, I will show you the picture of the separators in Google, then I can easily explain it. Okay. Okay. Right, so using different methods we can collect gases, right? Okay, now you just look at this one. Okay, now let's say we are going to produce H2 gas by reacting sodium with water, right? So you just take some water here, right? You just take some water here, and these are sodium solids. So what will be produced? H2 gas will be produced, right? So through this delivery tube H2 will travel, and you have to immerse a completely filled gas collector jar, right? So this is a jar. Now you have to completely fill the jar with water, and without losing the water you have to immerse into a beaker containing water invertedly. Okay, invertedly mean upside down. Okay, do you understand?
Okay.
First you have to take a jar, and you have to completely fill it with water, and you have to cover it with your palms, right? You have to cover it. Now I will just okay, can you see my video now?
Yeah.
Okay, now let's say this is our jar, right? So you have to completely fill. Let me stop share this. Okay, now let's say this is our jar. Okay, so what you have to do is you have to fill this jar completely with water, and you have to cover it with your palm, and you should have already taken a beaker containing water, right? So you should cover it completely, and you have to invert, and without losing the water you have to immerse it into the beaker. Okay, right. So what you will have is, now let me stop this. Right, so initially what you will have is the jar is completely filled with water. When gases evolve, it will be collected in the jar, so the water level will reduce. But initially the water level was till this point, right? But when the gas is collected, gradually the water level will reduce. So this is how the oxygen gas and hydrogen gases are collected. Now the weight of hydrogen gas is very less, because the atomic number of hydrogen is 1 and the molecular mass of hydrogen is just 2, right? So this is very smaller gas, so it will always, the density of the hydrogen gas is very less, so it will always tend to float, right? So it is collected through the downwards displacement of gas. You should have definitely studied this in your previous grades. Didn't you study them?
No.
Okay, now you see the water is displaced downwards, right? So when the hydrogen gas is collected into the gas jar, water is moving downside, right? So
Yeah.
this is called downwards displacement of water. Downwards displacement of water. Okay, right. Now you see, if we want to collect carbon dioxide, right? So in a reaction, carbon dioxide is produced, right? So carbon dioxide is a weight, the weight of carbon dioxide is very less, very high, I'm sorry. Very high means it is not moving upside, right? It will always, now if we drop a heavy object, it will always tend to go downwards, right? So okay, now let's assume through this right uh, right, through this delivery tube CO2 gas is coming, right? Now if we want to collect CO2 gas, right, so we will use this setup, right? So we will just insert the delivery tube into a beaker, so it will be collected, carbon dioxide will be collected here. Again we can use, okay, now if we want to collect CO2 gas, we cannot use the upward downwards displacement of air. Now this method is called upward displacement of air. Why? Because a new gas is coming, but earlier the gas jar is filled with air, right? But when carbon dioxide enters, the initially confined water is moving upwards, right? So this is called upward displacement of air. This method is applicable for heavy gases, like carbon dioxide. Okay?
Okay.
Right. But if we want to collect carbon dioxide, this method, downward displacement of air, is not possible. Why? Because even if it is collected into this jar, due to the due to the heavy mass of carbon dioxide, again it will escape. Why? Because it will always tend to go down, right? Carbon dioxide is heavy gas, so it will always tend to go downside if there is any chance. So here this is open, so it will always try to escape. So using this method, downward displacement of air, we cannot collect carbon dioxide. But if it is H2 gas, now let's say if it is H2 gas is very density of H2 gas is very less, so it will always tend to go upside, right? So when we collect, so always H2 will tend to go upside, but there is an obstacle, so it will be collected here. Can you understand the idea?
I think so, yeah.
Okay, so this is called downward displacement of air. So H2 gas can be collected using two different methods. What are they?
Downward displacement of air.
Downward displacement of water and downward displacement of air. Carbon dioxide can be collected using two methods. We can use this method also, and upward displacement of air. Why? Because initially the jar contain air, so the air is moving upwards since the carbon dioxide is collected. Okay, so these are the three methods that we use for collecting gases. Okay, in your previous grades you should have studied, but we don't need to focus here, right? But if time permits, later we will study.
Okay.
Right. So you just want to know that gases are collected in three different methods. Okay. Right. Collecting hydrogen gas. Okay, now let's see this. Okay, if you click on the link, it will direct you to a new window. I don't know if you can see that window. Okay, let me stop sharing. Right, I just clicked on the link in the PDF and it directed me to this page, right? So generating, collecting and testing gases, right? Okay, we will first study this, right? Because they might ask question from here. Okay.
Okay.
Right. So general gas preparation. Generally, we need to prepare H2, O2 and CO2 gases in the laboratory. For that, we will use different chemical reactions, right? So if we want to, for example, if we want to prepare or generate H2 gas, we can simply react any metal with water, right? Okay, now let's say this is a solid reagent, this is tube. Okay, right, so this is how the initial apparatus should be set, right? So the diagram below shows a typical set of apparatus which can be used to prepare range of gases, right? So you see now the this funnel, it should have a long tube and it should touch the bottom of the flask that we are using, right? So why we are now the funnel should be dipped into the liquid. Why? And the delivery tube should be above the liquid level, because here when the reaction happens, now let's say we have not immersed this funnel till the, okay, now we have only fixed this funnel till this point, right? So what will happen? The gases generated will escape through this tube again, right? So but if we immerse the funnel below the water level or below the acid level, then we can protect the gas from escaping through the funnel, right? But the gases will be evolved here, right? Now the gases are produced like this. Now through this hole the water will come, I mean the gas will come, right? But why? Okay, now they might ask why we immerse the funnel into the liquid level. What is the reason?
To not let any other
To let the
reaction
not let the gas escape, to not let the gas escape from the system. Okay, we Okay. Right. So whatever the gas it may be, we can collect them using three methods. What are they? Upward displacement of air and downward displacement of air, and this is also called downward displacement of water. Downward displacement
Okay.
of water. Okay. Right. Now if we want to carbon dioxide, right? So slowly oxygen. Okay, so we have to use specific reactions to collect the to actually generate the gases, right? So that's what we are going to study in this chapter. Let me stop this and share. But where's that? Okay. Can you see my screen now?
Yes.
Okay. Okay. Right. Okay. So if it is active metal, then it will produce metal hydroxide, right? So you should know that. Have you studied about the group, periodic, and other stuffs in general chemistry?
Right.
You know periodic table.
Yeah.
Okay. So here we will say lithium, sodium, potassium, rubidium, and cesium. So these are first group elements. Then beryllium, magnesium, calcium, strontium, and barium, right? Okay. Now these metals will react with water and produce hydroxide, right? But if you consider this beryllium will react only with steam, right? Steam. But this magnesium will not react with cold water, but it will undergo a slow reaction with hot water and steam, right? So we can classify water into three categories: cold water, hot water, and steam, right? So cold water and hot water are in liquid state, whereas the steam is in gaseous state, right? So what is the difference between cold water and hot water is the temperature. In cold water it's at room temperature, and hot water means it's somewhat rise in temperature. Okay, so this is just deep things. Let me just go through this first. Yeah, you see now. Okay, right? So this is what they have given here. Okay, so I will teach you in different way. Okay, so yeah. Okay, so what I told you now is we can classify. Okay, let me use this one. Right, so we have cold water, right? Then we have hot water, right? Then we have steam, right? So now cold water is at room temperature, right? So at room temperature, and how it dissociate is H plus and OH minus, H plus and OH minus, H plus plus H plus N OH minus.
minus.
OH minus. Okay, it should be a superscript plus. Okay, I cannot type like that. Okay. So H plus N OH minus. Then
Yeah.
hot water. So hot water will dissociate as H plus NOH minus, but we can say H plus NO2 minus also, right? So we have two kind, right? So according to your, now this is also H plus OH minus, but this is a bit advanced. So let me just, here they have given two different, yeah, steam. Yeah, as I told you, see the reaction of magnesium metal with steam, right? So steam, right? So you see now hot water also will dissociate as H plus and OH minus, but this steam will dissociate as H plus NO2 minus. How? H plus NO2 minus, 2H plus NO2 minus, 2H plus NO2 minus. Okay, so if I consider steam, that is also H2O, that is also H2O, but H2O gas, right? So if it is cold water and hot water, we will write as H2O liquid, but the only difference is temperature. But here H2O gas, right? If it is H2O gas, then it will dissociate as H plus 2H plus NO2 minus, 2H plus NO2 minus, 2H plus plus O2 minus. I'm really very sorry for the annotation because I'm using my mouse to annotate here. That is a bit difficult for me. Okay. Right.
Okay.
Now H2O liquid. So it may be either cold water or hot water. H2O liquid. It may be either cold water or hot water. It dissociates as H plus and OH minus. So this is what we are going to use to predict the products, right? H plus and OH minus, right? So can you just mark this down? Huh? So as I told you, I have just written the first and second group elements of the periodic table. Only the bounded metals will show reaction with cold water, but beryllium will only react with steam, and magnesium also will react with steam, but it can react with hot water also when the temperature increases. Why? Because the reactivity, due to the reactivity. Okay, because it cannot lose electron at some circumstances. That is the main reason. Okay.
Okay.
Right. Now what you should know here is, see here Na. Okay, now sodium, right? So here sodium can react with even cold water. So when the condition increases, now cold water, now mild condition, the temperature is at room temperature, but hot water the temperature is high. If we increase the temperature further, then it will become steam, right? So the condition increases. Do you understand that point? The condition increases from cold water to hot water to steam. Especially the condition is here the temperature. Okay?
Okay.
Right. Now you just consider this sodium. So this sodium will give you Na plus, right? And this H2O liquid. So if it is H2O liquid, then it will dissociate as H plus and OH minus, right? H plus and OH minus. So here Na plus is there and H plus and OH minus is there. So I'm just writing over here Na plus and H plus and OH minus. H plus OH minus. So as I explained you earlier, this Na plus and OH minus will come together to form NaOH, and this isolated H plus will make a covalent bond with another isolated H plus. to produce H2, right? Now we'll come to the second scenario. If it is less reactive metal means it's magnesium. If it is okay, now if one side is less reactive, the other one should be high reactive. That's why we increase the temperature to form steam to make a less reactive metal to form a product. Do you understand? Now let's say there are two people, right? Now there are two people. Now let's say now he is not interested to study, right? He is not interested to study, but if we want to make him study, the other guy or his friend should be a studious person. Then only he can motivate him and make him study. Do you understand that? Okay. Likewise, if it is a less reactive metal, the other one means here water, right? So the condition of water should be high, which means we have to increase the temperature to make the reaction happen. Do you understand? I just told you an analogy. Okay. So this is a active metal. Active metal means it easily reacts with water. But if it isn't less active metal like magnesium or beryllium, so we will see what will happen if we use less reactive metal. So here you see less reactive metal will only react with steam to give metal oxide and hydrogen oxide. Now we will see how this reaction occurs. Okay. So here this magnesium will produce Mg2 plus. That is obvious because it can lose only 2 electrons, Mg2 plus. But you see H2O gas, if it is in gaseous state, then it will dissociate as H plus and O2 minus. H plus and O2 minus. How many H plus? 2H plus and O2 minus, right? O2 minus. So now this Mg2 plus is more reactive than H plus, but initially the oxygen had a relationship between this H plus. But when oxygen sees a stronger guy than this H plus, that is the character of anions, right? So if it finds a strong guy, then it will go with that strong guy, leaving the guy that it had relationship with, right? So that is, I just tell you this example to make you understand easily, right? So Mg2 plus will now this oxide will now make a new bond with Mg2 plus to form MgO, right? So we will just exchange the Mg2 plus and oxide O2 minus. So valency 2, right? So MgO, right? Mg2O2, then we will use the simplest ratio. So MgO, then these two H plus are isolated, so they will come together to form a covalent bond and H2 will be formed. This is how the reactions happen. Okay?
Okay.
Right. Now dilute acid, oxygen. Do you have any examinations or tests recent in the upcoming days?
Oh, no.
Okay. Now, when will your next term examination be conducted?
About 8 weeks.
I'm sorry?
8 weeks, about 2 months.
After
Somewhere
2 months,
around
right?
2 months.
After 2 months only you will have your next examination.
Yeah.
And what was your marks in chemistry in the recently held examination?
The recent one we haven't got back yet.
Okay, before that?
Before that it was, what was it? I think it was like 85.
85. So if you have your corrected paper, can you send me that as a PDF by scanning?
We didn't get it back.
Or it's not available?
No.
Okay, that's fine. What's the time? Okay, so I will give you 2 minutes time to just go through what we have studied in the second session. Okay. Shall we continue?
Yeah.
Okay. So here we discussed two scenarios, one with active metal and less active metal. So active metal can even react with cold water, but if we want to make a less active metal with water, we should increase the condition. So here the condition is temperature, right? So when we increase the temperature, then we will form steam and we can produce metal oxide, right? But in both scenario, our objective is to produce hydrogen gas. Okay, right. Now dilute acids. So what do you mean by dilute acid? So what is the opposite of dilute acid? So we have already discussed acid, right? So acid means it should release H plus hydronium ions in the aqueous solution. Okay. So now if the amount of solute, so for example, let's say if the amount of solute is high in a solution, it's called concentrated acid. If the amount of solute is less, then we will call it as dilute acid. So how can you make how you can make dilute acid is just by mixing water. It's just by mixing water. Okay, right. Now if you take concentrated acid, now concentrated acids are readily available in laboratory, but if you make or if you perform experiments using concentrated acids, then it might cause some dangerous effects. So always we prefer to take dilute acids for our experiments, right? If we don't get desired output only, we will go for a concentrated acid. So we will first discuss how metals act with dilute acids. So you see now magnesium. Okay, now this is the general form, right? So magnesium HCl, right? So how will it happen? So magnesium will form MgCl2 and HCl, H plus Cl minus. The same story is applicable here as well, right? So Mg2 plus is there and Cl minus is there. So comparing the reactivity, Mg plus is strong, right? So this Cl minus is again anion, so it will form a bond with Mg2 plus and MgCl2 is formed. Then the isolated H plus is H2. Okay, that's all.
Okay.
Right. Now, due to the vigorous nature of this reaction, it's not suitable to conduct this reaction with more reactive metals. So now you see in the reactivity series, we have taken the third metal, right? But if you put magnesium, then again it will explode because the reactivity is very high. Okay. So, right. Now, it's not suitable to conduct this reaction with concentrated oxidizing agents due to the production of nitrogen dioxide when using nitric acid and sulfuric acid. Okay. Right. Now, if you use HCl, it will produce H2 gas. Now, if you use H2SO4, SO2 gas, sulfur dioxide will be produced. And if you use nitric acid, NO2 gas will be produced, right? Do you understand? Okay. Now I will just give you some examples, right? Now can you try to write down where how okay, now can you just try to write down this one? Okay, sodium plus HCl. Okay. What will be the products? I'm sorry?
NaCl plus H2, right?
NaCl plus H2, right?
And then balance it or no need?
Yeah, you have to balance it also.
Okay.
So NaCl
Cl
plus
H2.
H2. So what you
So
then?
So you put a 2 in front of the HCl
Yeah.
and a 2 in front of the NaCl and then a 2 in front of the Na
Very
as well.
good, very good. So you should, after writing every chemical reaction, you should make sure that they are balanced. Okay.
Okay.
Right.
And
Now,
if it's an incomplete combustion, then
I'm sorry?
do you still need to balance that?
I'm sorry.
If it's an incomplete combustion, do you still need to balance it?
Yeah, it doesn't matter whether incomplete or complete combustion. All the chemical
Yeah.
reactions should be balanced. So the number of atoms in the reactant side should be equal to the number of atoms in the product side. So that is the basic
Okay.
concept. Okay. Right, now oxygen, right? So oxygen is a non-metal, so if we put metal in contact with oxygen, it will produce metal oxide. So this is basically rusting, right? So if you put Fe now, okay, now if you have ionic products, right? So let's say Fe, now you know rusting, right? You know
Yeah.
rusting, right? So Fe2O3, right? So iron oxide is formed, right? Iron oxide is formed, so metal oxide, right? So when a metal is in contact with oxygen, basically if we expose a metal in environment, definitely it will in contact with oxygen, so it will produce metal oxide, but they are very slow reaction, if we want to make them happen fast, we have to add catalyst. That's the thing, right? Okay, so you
Yeah.
just see it can be anything, right? So if we want to make this one Fe2O3, I will say Fe, right? Fe solid, Fe solid plus oxygen O2 gas plus O2 gas will give you Fe2O3 metal oxide, Fe2O3. Now this Fe is a 3D block element. Have you studied about 3D transition elements?
No.
Okay.
Oh, the 3D suborbital elements?
Yeah, did you study them?
Yeah.
Okay.
Yes.
So Fe can exhibit two oxidation states, 2 plus and 3 plus. Here 3
Yeah.
plus, right? So 3 plus 3. So Fe2O3. Now can you try to balance this reaction?
Feet. With my pen. Oh, yeah. You would have to put a 3 there and then a 2 and then 4. Okay. So I can't get my pen out. Give me a sec. Okay.
Done?
I'm about to.
Okay.
So you would put a 2 here, and then you would put a 3 here, and then you would put a 4 here.
Very good. Right. Now if you take aluminium is also can undergo rusting, right? So it is also a very slow reaction, so it is also balanced, right? So as a teacher demonstration, magnesium metal, right? Now here there is a problem, because not always oxide will be formed, right? So for example, let's say okay, now we will say lithium. Now we have two kinds of oxide, right? So if it is O2 minus, we say oxide. Then if it is O2 2 minus, right? If the oxidation state of oxygen is minus, then we will say ferroxide. And if it is O minus half, that is superoxide. You know these things?
No.
Okay. So I think they have not included this. So okay, you just forget about this. Okay, that is not necessary.
Okay.
Right. So in all the now when we react a metal with oxygen, always oxide will be formed. But for some metals, ferroxide and superoxide also will be formed, right? So we don't need to bother about that. Yeah, wait, I will just yeah, okay, we don't need to study about that. Okay, so now if you use magnesium, so this is what they are telling, magnesium plus oxygen. So what will be the product? What is the product? Okay, sorry for the interruption. I experienced a network issue. Am I audible now?
Yeah.
Okay. So Mg plus O2, what will be the product?
Magnesium oxide.
Magnesium oxide, MgO, right? So when we burn magnesium strip, now it will ignite with a blue white color flame, right? So uh, okay, so I think by just clicking on this magnesium metal, this one, can you see this? You can see this experiment, right? How it ignites, and we have to the magnesium metal should touch the blue flame of the Bunsen burner, and it will ignite with white flame, right? So white color, lightning will be formed. Okay, right. Oxide powder, magnesium oxide solid. Now it will be like powder, right? So it will be like powder, solid, but powder form. Okay, not like chunk of solid. It will be in the form of powder. Okay, right. Now we have other metal ions in solutions. Metal activity series, ionization, atomic radius. Okay, these things we will cover in the next session. Before that, I have some questions to ask. So I hope your examination, now we have to plan, right? So I talked to your mom. Okay, I talked to your mom. She told me that you have 4 modules for grade 10 and 4 modules for grade 11, right? Am I right?
No, 4 for grade 11, 4 for grade 12.
I'm sorry?
4 for grade 11 and 4 for grade 12.
Okay. So when will you having your final examination?
Like for 11 or 12?
Okay. Now when will the next examination be held?
In about 2 months.
But after 2 months. So after 2 months, what examination will you write? Is it a term exam or final exam?
Final for year 11. So
Final for year 11, right? Okay, final for year 11. For that examination, we have to cover 4 modules, right?
Yeah.
So the 4 modules four modules were sent to me, and we will try to finish them off. And from your end, you have to download some past papers, because we can study all the concepts, but we have to know how the questions are asked, and we have to prepare accordingly. Then only we can ace the exam, right?
Okay.
So we can study. We cannot only rely on the notes and the theoretical stuffs. We have to know how the questions are asked, and from that we have to prepare. Then only we can write the exam effectively. Okay, because doing past paper is very much important when we are preparing for an examination, because examination they will definitely ask the questions based on the past question types, right? And 4 modules have been sent. We will study all 4 modules. Now module 1, right? So now for this exam, module 1, module 2, module 3 and module 4, right? Module 4.
Yeah.
Now we are studying module 3. Now I think next week we might try to finish this off. After that, what should we do? Should I revise the module 1 and module 2, or should I jump into module 4?
I think we should go through module 4 and then do module...
Okay, now what module are you studying in school?
We're just finishing module 1.
Module 1, right? Okay, then fine. So who taught you module 2?
Oh no, we're doing in a weird order. So we've already done module 2, and we're done with module 1 now, and then in school we're going to do module 3 and 4 quickly, essentially.
So
Before-
did you skip module 2?
No, we did module 2 first.
You have completed module 2 and module 1 in school, right?
Yeah, and then now we're about to start module 3 and then
Okay.
module 4 as well.
Module 4. So we are remaining with module 3 and 4, right? So after completing
Yeah.
all modules, we will practice some past paper questions, right? So you have to
Okay.
make arrangement for the past paper questions, and when we are trying the questions, we will just revise all 4 modules also, right?
Yeah.
And okay, now it's my habit, now it's time to wind up the session, and I have done 2 sessions, right? So I always expect feedback from my students, especially the negative
Okay.
things, right? So feedback in the sense you should include both positive and negative, and what you expect from me and how I should
Yeah.
teach you, right? So this is what you have to mention in your feedback. You just send me a type message on WhatsApp, right? So
Yeah, okay.
I know my strengths, but you should mention my weaknesses and how I should promote my teaching strategies. Okay, you can include them, and you can just freely. You don't need to be reluctant. You can freely mention what your expectations are. Okay.
Okay.
Right. So we will meet next week, and if you have any questions, you can ask. Even on WhatsApp, you can. If when you are studying yourself, if you struggle, you can just send me a WhatsApp message during my free time. I will try to explain them. Okay.
Yeah, okay.
Right. So we'll meet. Bye.